Hi everyone, in today's episode we're going to launch the training of our cars. So we'll be training a population of 100 cars. Please note that the population size is something important. The idea is very simple. The more citizens we have, the more diverse the solution will be. This way, the learning process will be faster. In Generation 0, cars have no idea what to do. Most of the cars didn't even reach the first checkpoint. However, we got lucky enough to have two citizens that managed to go further than the majority of cars. In Generation 1, two cars managed to amazingly go past two turns. One of them went outside the track afterwards, and the second one decided that it was best to stop accelerating in the middle of the track. We can see that our last surviving car was too confused and hesitated too much until reaching the maximum lifespan. In Generation 5, some cars managed to go even further on the track. In Generation 6, an interesting behavior emerged. A car managed to go past the two first turns, then went straight forward like the other cars. Just before going outside the track, it went backward to adjust its path, then continued the progress to go past another two turns before crashing on the sharp turn. In Generation 9, two other cars managed to reach the sharp turn. One of them managed to get there faster without even stopping at the third turn. The genetic algorithm found a way to reach the same goal with an optimized solution. In Generation 12, a car managed to pass through the sharp turn without crashing. Sadly, it went outside the track just after that. In Generation 14, a new interesting genome emerged. This time, the car managed to make an impressive progress. Then it went outside the track when taking the last turn. In Generation 15, we got the first car that made it to the finish line. We can say that we already found a solution for the problem, but is it the optimal one? Let's train our model for a few other generations and see what happens. In the next generation, 4 cars made it to the finish line with different times each. At this point, I knew that the training would turn into a racing game. In Generation 20, almost a quarter of the population learned how to make it to the finish line. Ten generations after, 70% of the population made it to the finish line, and it was really looking like a racing game. Spoiler alert. It was also at this point where we got the fastest time a car can reach on this track. Surprisingly, in Generation 50, fewer cars made it to the finish line. This proves that crossovers and mutation don't automatically create better offsprings. Thankfully, we used elitism to carry our best driver to the next generation. I kept training the model to see if we will end up with a population where all cars are able to drive to the finish line. After reaching the 100th generation, I knew that the answer was no. This actually makes sense, since my selection algorithm wasn't too brutal to drop the worst performers. I decided at this point to stop the training process. With this last run, we arrived at the end of this series. I really enjoyed working on this project as well as working on these videos. The project source code is available on GitHub. The link will be in the description below. Thank you for watching this series and see you next time, hopefully with another project.